This video lecture is focusing on quantitative data analysis. These are some of the learning objectives for this week. Take a moment to pause here. Those highlighted in bold are the ones that will be covered by this lecture. This is a review of one of the tables in the chapter for this week, looking at steps in analysis of quantitative data. Some of which should be familiar to you, and I also just want to give you a heads up of how this connects to looking at our class survey data. So we have already, as a class, done parts of step 1. We have collected data, and when you get to the assignment or the activity that looks at the survey data, that will be parts 3 and 4. And what this lecture is focusing on is parts 5, 6, and 7, or steps 5, 6, 7. So first, I want to give you an overview of measures of central tendency. So they all start with the letter M, mode, median, and mean. And that's sort of the technical term, measures of central tendency, but you might also see them as averages. And this is probably familiar to most of you. The mode, or the modal answer, is the most common score. The median is that middle score or middle category, and the mean is what we typically think of as the average. Right? You add up the scores and you divide by the number of cases. So if these are the students' scores on an exam, the mode would be 70, the most common answer. The median would be 80, that number in the middle, and the mean, if you were to calculate it, is 79.3. There's also a few other ways to look at the mode. You might look at, and this also connects to learning about different levels of measurement. So if you ask what are the most, or if you have data on what are the most common foreign languages spoken in the US, which is a nominal variable or nominal level of measurement, the most common foreign language, non-English language, is Spanish. So the modal language, the modal answer is Spanish. You might also look at the mode graphically. This is looking at people's health condition, rating it from excellent to poor. And the most common answer, I know the colors are not great, but the most common answer is good. Right? Nearly half of the sample reports their health is good. So just go ahead and take a moment, pause here, and see if you can calculate the mean, median, and mode. If the example is, how many days last week did you go to work? And this was asked to 7 different people. So make sure to pause here, figure it out. And the answers are: the mean is 3.57, the median is 4, and the mode is also 4. I also want you to be able to calculate a percent. So we usually think of a percent, and this will connect to looking at frequency tables. The number in the subgroup divided by the total group times 100. If you're looking for what percentage of the sample is female, so let's say there were 42 females out of 70, that is 60%. Okay, so this is a frequency table. So it's asking people what is the ideal number of children, and their answer choices were 0 through 5 or more, and these are the answers that people gave. So frequency table tends to include the actual counts, but also the percentage. And the way it's calculated is how many people answered 0, 15 out of 1131, which ends up being about 1%. All right, so make sure that you can do this as well. So let's say another variable, and we produce a frequency table, is looking at years of education completed, from 10 years to more than 16 years. Take a moment to pause here. How would you fill in the blanks? How would you calculate the percentage that have 11 years of education? And so on. Also, once you're able to calculate the percentages, I would ask you to identify what is the modal response. What is the most common response? So again, take a moment to pause here. Moving on, you see I filled in the table with the percentages, and the mode is 12 years, the most common answer. All right. So something you might not be as familiar with, but is very important in quantitative analysis, is not only looking at the measures of central tendency, the mean, median, and mode, but scholars are also interested in the variability. And variability are a few different statistics for numbers that indicate the spread, the distribution of scores. One common one is the range, looking at what's the highest score, what's the lowest score. And another one that you perhaps will see the most often is something called the standard deviation, or SD. And we're not going to learn how to calculate it by hand, but you would learn this in a statistics course. So the definition is the average amount by which scores differ from the mean. Okay. So let's say there's an exam scores, people have the scores from 0 to 100. The mean is 85 and the standard deviation is 5.5. Oftentimes, but not all the time, we think about we expect all the scores to be within 2 standard deviations, and that means 2 standard deviations above and 2 standard deviations below. So in this case would be between 74 and 96. But that's less important than understanding it conceptually. So I think this diagram will help you, and then we'll come back to this slide. So let's say we're looking at, this is a study that's looking at the mean ages of women in 2 different occupations, right? Women that work in clerical type of jobs and women that work in technical jobs. So they found for the 2 groups, the clerical jobs, which is on top, the mean is 39.46, and the mean for the technical jobs is 39.87. So those means are very similar to each other. However, the standard deviations are quite different. And what that means, as you can see graphically, is that on the top, the respondents are kind of more spread out, right? There's more variation. There's some people that are far from the mean, right? Other folks that are closer, as opposed to the technical jobs where, yes, the mean is about the same, but the standard deviation is smaller. People tend to cluster closely around that mean. Another way to think of this is that a larger standard deviation, there's more of a range in answers. People respond differently. There's more variation. And a smaller standard deviation, there's less range. There's less variation in responses. And I find standard deviation to be easiest to understand in a situation like this, where you're comparing 2 groups. So here's another example. Let's say there's a middle school, and they're collecting data on how often students experience bullying. So they ask students, how many times have you been bullied in the past month? So in school A, the mean is 3.5, and school B, the mean is 6.2. So yes, the schools have different means, right? Children in school B tend to get bullied more often, school A less often. But we're not just interested in the means, we're also interested in the standard deviations. So which of the schools has a higher standard deviation? And what does that mean for the experience of the students in the school? And we could even think, what does that mean in terms of designing an intervention? Right? So in school B, the bullying is higher, but there's less variation in the scores. Everybody tends to get more likely to get bullied about the same amount. In school A, there's less bullying going on, but there's a lot more variation, right? So some students are going to have experience that's closer to the mean, and then other students are going to have much less and much more, right? So that's very different if you think of how do we reduce bullying in the school. That's very different if everybody's getting bullied versus only certain types of students, perhaps. Okay. So the next concept is something called statistical significance, which you will also see quite a bit. And the definition of that is that we think that whatever statistic we're looking at represents something true, represents a true pattern in the data, represents something really going on, as opposed to it just happening by random chance. We think that this represents a true pattern. Oftentimes, statistical significance is indicated by stars or asterisks that indicate that it is statistically significant. So if there are these asterisks, then it is, yes, it is statistically significant. If there are no stars, then we cannot say that there is a statistically significant relationship. These stars correlate to something called a p-value. And a lower p-value is better, more likely to be statistically significant. Okay. So generally speaking, in most research, these p-values, 1 star is a p-value that's less than 0.05, and 3 stars is a p-value that's less than 0.001. But really what we care about is, are there stars, yes or no? Okay, so let me show you an example. And this is an example from my own research on living arrangements of older adults with their children in China. And in this case, I am comparing 2 groups of people. So I'm looking at the people in my sample that live with a son and the people in my sample that live with a daughter. And the table is showing us either the mean or the percentage in that category and the standard deviation. So for example, those who live with a son have a mean number of daughters, 2.11. Those who live with a daughter tend to have on average, have slightly more daughters. Then we have the p-value and we have the statistical significance test. And this is saying that the data show a true, and we believe it to be a true pattern, that older adults who live with a daughter have more daughters on average than people that live with a son. Okay. Similarly, we can also look at the percentages of things, right? And we see that people who live with a daughter, only about 50% of them used to work in agriculture, used to be farmers. Whereas those who live with a son, about 74% of them used to work in agriculture. So a greater percentage work in agriculture, and it's statistically significant. We don't find a statistically significant difference between those that are currently married or not. Okay. So you often see these statistical significance stars in a lot of different situations. You come across this in the papers that you're reading, but I find looking at 2 group comparison is kind of a good way to start. Okay, the next video will pick up with descriptive and inferential statistics.